Imagine if every fruit on this farm could be counted instantly, not by hand, not by guesswork, but through the power of computer vision. Solutions like this make production forecasting easier. Today, agriculture is not just about growing crops. It's about precision, efficiency, and data-driven decisions. With computer vision, farmers can do much more than just count fruits. They can monitor crop health, estimate yields, detect diseases early, and even optimize harvesting. From orchards to large-scale farms, computer vision is transforming agriculture into a smarter, more sustainable industry. And it all starts with simple innovations, like this fruit counter, that scale into powerful tools for the future of farming. In this computer vision tutorial, I am going to show you step-by-step way how you can create a simple camera-based fruits counter using YOLO.
Welcome to this computer vision tutorial on fine-tuning YOLO for fruits counting. In this tutorial, we are going to learn how you can train your own YOLO model on custom fruits dataset and use that model to count the number of fruits in a video and in real time. So to do that, you have to follow some simple steps. First, you need to create a dataset. For that, I'm using this video as a reference for this tutorial. As you can see, it's showing the numbers of cherry fruits on a tree. So let's create a data set. So to do that, I have created a library called YOLO fine tune utilities. So you just have to clone this library. When cloning will be done, this library will look like this. It has a script called frame extractor, which are going to be used in this tutorial. So you just need to import that extract random frame function from that script using YOLO fine-tune utilities dot frame extractor, and then provide the arguments like the part to that video, the output directory name, and the number of images you want to extract from that video, and a random seed value. When you run this function, it will extract 20 frames from that video into a folder called dataset. This is the folder which contain all the 20 images from that video. Now our next step is to upload these images on our labeler platform and use our tool to annotate these images on our cherry class which we want to detect. Let's go to our labeler platform to annotate these datasets. After uploading our dataset on Labeler platform, you can create a class called Cherry. As you have seen, this is the class Cherry I created for polygon segmentation. So you just have to click the Cherry class and select the object which you want to detect. I am using the SAM model for easy segmentation. So let's click it. As you see, labeler platform will annotate it automatically. So let's press enter. Now our this cherry object has been annotated. So let's select another cherry. Now this has been uh, annotated. We have to keep repeating this until all the cherry has been annotated. Our final result will look something like this. As you can see in this frame, I have detected 26 cherry. Now, our next step is to accept that and keep repeating this process until all of our 20 frames has been annotated. So let's get to our next step in which I am going to export this annotation in CocoJSON format and convert that into YOLO format. Let's get to our next step. When the annotation process is completed, you can export your annotation in CocoJSON format. It will look something like this. This is the CocoJSON format which store our annotation. So To train our YOLO model, we have to convert this into YOLO format, which is the structure in which one directory will contain all the images and other directory called label will contain all the uh, label segmentation points. So to do that, we just have to use our previous library which I have created and use Coco YOLO converter dot segment seg converter and import Coco to YOLO converter and provide it with the arguments of the parts to CocoJSON annotation, CocoJSON annotation, dataset directory, which is this, and the output directory name and a random seed. When you run this function, it will create a folder called YOLO format, which will contain all your dataset and annotation in YOLO format. As you can see, image directory contain all your dataset images and label directory contain all the annotation in the required YOLO format. So let's get to our next step of model training. To train your YOLO model on a custom dataset, you have to just import YOLO from Ultralytics and then use this command line called YOLO where task equals to segment, mode equals to train, and data will be the part to your data.yml folder and the model equals to the model you want to train on. I'm using YOLO 11M segmentation and epochs will be the number of times you want to train your models on whole data set. So let's run this. When you run this, there will be a runs folder will be created. It will contain a train folder and that train folder there will be a weight folder which contain your model's weight in best.pt and last.pt. Let's see a result on the video of tracking of your custom model. Let's run this. As you see, our model is working perfectly. Now we have to create the logic on how we are going to count our fruits. So let's get to our next step. For fruit counting, I'm going to use a simple logic. I'm going to draw a line on the screen, and if a detected object of class fruit is passed through that line, it will increment our value of counter by 1. So let's provide the part of the video and then see a sample frame of the video. So this is the sample frame of the video. As you see, I'm going to build my line around somewhere here. It will be around uh, if the let's see the height and breadth of the screen. So it's around 1920 1080. So I'm going to make my line around 1500. So let's build it. And the x value will be around 1500 and to cover create a straight or vertical line I have to provide the initial and the last point of y value. So 0 to 1080. Let's save the line value and then draw the line on the screen. So this is the line I'm going to use for counting line, and if a detected fruit is passed through this line, it will increment our counter value by 1. So let's go build this logic. Now we are going to create the fruit counting logic. I have created it. Let's see. I have write some global variables like product counter, which is the counter which will increment when fruit is counted. Then a perform segmentation boolean, which is set true to CD segmentation visualization. And then the counting line. If the object is passed through this line, the counter will increment by 1, and the video part which I'm going to use in this tutorial, and the output video part and the model part. This is the part to the custom model which we have trained on our custom data set and the model confidence. Let's see the function. First, I created a function to load my model in global variable called model. This is it. And then there is a function I created, line intersection, to check if two line has been intersected or a point is intersected with a line. This function help us find that and return true. And then this is a function which take the position of point as the argument and use the line intersection function and increment the product counter by 1. Here is that. Now let's get to our main function. In this main function, I'm taking all the variables like video part, model part, and using it to load model, and then loading our video to cap variable and getting some metadata like FPS, width, height, total frame, and then I'm saving that video in out variable. Let's come to our main part. This is a product counter, which is a global variable, and a counted object to track if an object is counted or not. And this is the track history. It stores the ID of the values. Like if an object is given an ID on tracking, it will maintain its ID throughout the video. So let's come to our main logic. I'm using model and its track function to track across each frame of the video to track an object, and then from that model I'm taking the mask and boxes out. These are the bounding boxes and these are the segmentation masks, and this is a part where I'm going to use to check if the model if the object is counted or not. If the object is counted, it will show us in yellow color. If the object is not counted, it will show the mask in purple color. This is for just visualization of segmentation. Now here comes the logic. For each bounding boxes, I am finding its center point, center X and center Y, and checking if that center X and center is cross the line or not. So this, if it cross the line, it will increment the product counter by 1. So, and if that it's counted, it will change the color depending on the uh, variable counted object. If it's in counted object, it will the show us different color, and if not, it will show a in different color. And then these are just to visualization, like building creating rectangle on the detected object and putting the ID name on it and the a circle on the center of the object. So, and these are the logic to draw the line and the name counting line. So these are just extras. Let's run this and see the result. As you see in our result, with or without segmentation visualization, now you know how you can create a custom model of YOLO on your own custom data set and use computer vision to count it. Now let's see you on our next tutorial.
For more computer vision or machine learning related tasks, you can check our GitHub, where you will find everything in one place.